In this video, we're going to break down concavity. What is it? What causes it? And how are we going to find it? So a couple things we're going to be talking about. So what is it? Concave up, we learned in the last section. That's whenever you have your smiley face in the graph. It's opening upward. You can see that here, opening up. So what causes that? Well, that happens when our slope is increasing. Very interesting, because we've learned about when a function's increasing. Now we're learning about when its slope is increasing. So if I were to draw a tangent line, let's just say right here, and then I'm going to draw another tangent line. There, you could see the slopes are both negative. However, the slope of the second line I drew is a little less negative. It's a flatter curve. Flatter negative curve means a greater value. And as you can tell, if we're going to go from negative to the next value, we're going to go from negative to 0. If the graph will let me do this. So we're going to go from negative to 0. Means that it's increasing. So our slope going from negative to 0 means our slope must be increasing. And then we end up with a positive slope now. So from 0 to a positive slope, once again, our slope is increasing. And then it gets steeper and steeper. So what you can see here is that m is increasing. In other words, the derivative is increasing. F prime is increasing, right? So the derivative of this graph is increasing. So what does concave up mean? Well, that means that the derivative f prime of x is increasing. So I'm going to put implies f is concave up. So if f prime is increasing, then f is concave up. Now, how do we tell if a function is increasing? Remember, we look at its derivative to see if it's positive, right? So if f prime was positive, f is increasing. Now we're talking about if f prime is increasing, then f is concave up. Well, how can we tell if f prime is increasing? Well, we look at its derivative, and if its derivative is positive, then that tells us that f prime is increasing. So if the second derivative is positive, then f prime is increasing, then f is concave up. Similarly, you'll see the derivative, the slope, if it's decreasing, see it's positive, it goes to 0, then it goes negative. You can see our slope is decreasing. So if our second derivative is negative, then that means that f prime is decreasing. I just saw a little typo. Let me fix this. So if f double prime is negative, then f prime is decreasing, which tells us that f is concave down. So we're going to go ahead and look at the sign of the second derivative. We can figure out if the second derivative is positive or if the second derivative is negative, then that'll tell us if f is concave up or concave down. So let's look at this first problem. So we're not going to do a first derivative test. We're going to do what's called a second derivative test. And don't fear, it's the exact same process. It just tells us something different about the function. So I'm going to label it a little bit differently. So f prime of x is 12x cubed minus 48x squared plus 48x. Want to double check that. 3 times 16 is 30 plus 18, so that would be 48. That's correct. So then let's take our second derivative. And I'm trying to think, what do these all have in common that we can factor out? And I'm thinking 12 for now. And that's looking good. So we're going to do our diamond method now. 3 times 4 is 12, and negative 8 would be negative 6 and negative 2. Divide each one by 3. And I'll get x minus 2, 3x minus 2. And so now I'm going to draw a number line. Label our zeros, which will be 2 and 2/3. So 2/3 is the lesser one. 2 is the greater one. And if I plug in, so just doing our test real quick, just like the first derivative test, we're just going to call this the second derivative test. So I'm testing the second derivative right now. So if I plug in a 0, then I'll get a negative times a negative, which is positive. If I plug in a number between 2/3 and 2 is 1. If I plug in a 1, I'll get a negative times a positive, which is negative. If I plug in a 3, I'll get a positive and a positive, which is positive. So we want to know, when is it concave down? That would be right here at this negative, which is on the interval from 2/3 to 2. Why? Because f double prime is negative. That means that f will be concave down. And that's the idea. So it's just like the first derivative test, just now we're doing the second derivative. So it's not too big of a difference. So let's go ahead and look at another problem. That one kind of looks like a pain. That one looks like a pain as well. So I'm going to pick one and go with it. And I'll give a hint on the second one. So let's go with this one. So h prime of x is going to be negative. We'll put that negative just out in the front. So we're going to have f prime times g minus f times g prime over g squared. So it looks like a pain. Not a big deal though, because the 0 times that's going to cancel it out. We'll have a negative 2 on the top, x plus 3 squared, which becomes a positive 2 over x plus 3 squared. And actually what I should have done from the beginning was rewritten this, because this is a much easier derivative to take if you rewrite it. And let me show what I mean. This would be negative 2 times x plus 3. Distribute the negative 2, or no, to the negative 1. And then from there, so you bring it up to the negative 1, and then you just take the derivative, it becomes a positive 2 x plus 3 to the negative 2, then drops the bottom. Why don't I just go ahead and do that? So instead of doing quotient rule, because it's a constant on the top, that should have seen this from the beginning. Bring that x plus 3 to the top as a negative 1. So h prime of x is going to become a positive 2, x plus 3 to the negative 2. Times the derivative of the inside is just 1 if you do the chain rule, so I'm not going to put it. Now for the second derivative, and so now we're going to go ahead and do our number line test. And no matter what I plug in, it's going to be, oh, never mind, it's cubed, so it could be negative. So if I plug in a negative 4, so we have negative 4 on the top over x plus 3 cubed. I thought it was squared. So if you plug in a negative 4, you get a negative on the top over a negative on the bottom cubed is negative, which is positive. Then if we plug in 0, something to the right of negative 3, negative on the top, because it's negative 4, over 3 squared, or 3 cubed is positive. So that's going to be negative. So when's it concave down? Everywhere to the right of negative 3. So negative 3 and to the right. And that's it. This one, just to give a quick hint, you could rewrite this one as negative 27 times, or negative 27 over x minus 6 to the 1/3, right? And then bring that up to the top, just as we did in that last problem. It's going to make things a little bit easier for you, taking that derivative. It's still going to be the same set of rules. It's going to be a very similar problem.